I'm Aloys Osano, the Director, Center for Innovation, New and Renewable Energy within Masai Mara University. I'm a PhD holder in chemistry, biofuel, energy option. So now we will start off with the biogas production. Of course, it starts from acquiring materials and in form of cow dung, in form of kitchen waste, and those materials are put here. This is a withholding tank. This is a material withholding tanks which stays there for like 3 days before it is fed to the main plant. You open up that. Now these materials, actually we do use a cocktail of waste materials, kitchen waste, cow dung, and so many other materials which we mix. But remember, these are materials which can decompose easily within the time frame of 3 days. Now remember, we do close up our system, all our withholding plant, to hasten the decomposition period of this. Now you can see this is a cocktail of feedstock. In other words, kitchen waste is mixed with cow dung, and you can see the decomposition is signified by the presence of these maggots. That shows the material is already started decomposing and it is ready to be fed into our system. Now the materials I brought into stage 2, and it is placed, as you can see here, it is placed into a hopper. You fill the hopper to the brim before you open this. There's a channel here, or a tunnel, which leads to the main biodigester plant. So this is a hopper to hold the materials. The material needs to be filled to the brim such that you can increase the velocity or that speed within which the materials moves through the channel. The reason being, if it moves slowly, it is likely to block our channel because the channel is not so much wide, and this is to increase that speed and of course the pressure, so that the materials, the solids which you are seeing within this stuff can be pushed through into the biodigester. Now next, stage 3 is our digester. It's a dome-shaped, buried underground. The biodigester currently we have here, the capacity is 12 cubic meter, and this is a dome-shaped biodigester. This is now where you can see on top we have the gas line or the gas outlet. This is the gas outlet, and next, whatever is cemented there is our gate valve, the first gate valve controlling the gas output. Now, of course, from the gate valve, there's a gas pipe which is going towards that direction. It is underground to what we term as the gas testing point. You can see it there, where we have other biodigesters, small, we call it portable domestic biodigesters, 2 of them, where that is the joining point where the various biodigester gas produced from the various biodigesters meet at that gas testing point, where we have several other gate valves. So this is stage 3. So this is the dome, the biodigester. Then next is what we term as the stage 4. It is actually the sludge outlet, or the digested. Once the the feedstock has been digested and the gas has been extracted in the main biodigester. The outlet here, there is a release of what we term as there is a release of the digested, or sometimes called the sludge. Now, of course, this end is closed to avoid rainwater entering into our digester through the outlet. We prevent that by covering up the system, such that we prevent that rainwater from entering. Now you can see there are two pipes leading from the main digester. There are three pipes. Yeah, there are three pipes here. There's another pipe here. Of course, we have closed this amano from which we can be able to clean up our system in any case there's blockage. Okay, but then at the outlets there are three pipes which extracts the digested. Now this digested, we assume that we have not extracted fully the gas from the decomposed material or the digested material from the main plant. So again, we redirect it to another smaller plant. This now stage 5. So in stage 5, we have what we term as our other plant, which receives the biodigested from the first plant, in view of enhancing the efficiency of the digestion process. We expect to extract all the gas, and of course to digest all the what we term as the waste biomass, or the waste biomass, into a clear solution. So this is the smaller dome, and then after it again we have another outlet. We have another outlet from the smaller plant. Now the final digested is received here, and this is stage 6. This is now our final digested. This is like, now this one it will appear like it's so clear than the first one, the first digested, which we redirected to the smaller plant. Now this is to ensure complete digestion of the raw material. Then you end up having clear water. This clear water, in essence, it is just not water, but this is a fertilizer. Once you remove water, you will obtain your clear crystals. You will obtain your clear crystals. You can see it is actually like a clear water, and in most cases it's smellless, which means all the materials have been removed. That is the biomass materials. So now we have the minerals, the fertilizer, like phosphate fertilizer. We have nitrate fertilizer within there. And this water here is a fertilizer in itself. Without even removing water, you can apply in the field. You can see here, this is a demonstration plant, a demonstration farm. This is a vegetable demonstration farm. You can see how the veggies are done. And here, this water can act as both a pesticide and a fertilizer at the same time, both as a foliar fertilizer and as, of course, the root fertilizer. So you apply, you spray the whole plant. So it has pesticidal properties and it has the fertilizer properties. Okay, so it acts both. It acts as both, as a pesticide and as a fertilizer. So like now, this is clear water, and most cases this kind of water does not have microbials. There are no microbes in this kind of water. So when you spray your crops, you are assured of a clean, organic farm. You are assured of organic farm and organic, vegetables. without applying inorganics. Now, you can see from the smaller plant again, we have a gas pipe, an outlet, which is going to the other side to join the main plant gas line at the gas testing point. So we can check at the gas testing point, where again we have other smaller plants. We have two other smaller plants. These two plants are also on a testing mode. These plants, we call them, or digesters, we call them portable domestic biogas units. And one plant of this can satisfy gas production of a family of 5. No, a family of 3, not 5. A family of 3. They can satisfy a gas needs of a family of 3. And the feedstock for this is normally kitchen waste. We target the kitchen waste. Like each family is producing waste from their kitchens, so they feed it. Of course, you feed it through this point, and the outlet is here. And the gas line comes like that, right? So you can see it is a replica of that. So we have connected these two plants can produce gas in each case. Both are connected with non-return gate valves, such that no gas goes back. And then they join each other at this point, and then they are joined at the main. They are joined with the main gas lines at this point. They are joined at the main gas lines, the two gas lines, one coming from there, that is the main plant, and the other one from the smaller plant on the other side. So they join here. Now this is the gas testing point. This is the gas testing point. We can extract the gas here, but remember, this gas line goes all the way to the kitchen, to the university kitchen, okay? And it is being used as we speak. So this is stage 5. See, this is stage 7. This is stage 7. So meanwhile, can you be able to test whether there is gas? You can, sometimes we test gas by filling our, now we can only get the pressure of the gas. I don't know whether you're getting that pressure. Yeah, it can fill this temporarily, tube. We use them as storage of the gas. So it is being filled. So the pressure of the gas is quite high in sometimes, but now it is under use on the other side. But still the pressure is on. The pressure is high at the moment, and again it is being used at the same time within our kitchen. So this is our final product from the waste biomass. We obtain our gas, that is methane. Now our efficiency or the quality of our gas is 80 to 85%. The quality of our gas is 80 to 85%. And our first dome produces 2 cubic meters to 4 cubic meters of gas. Or rather, let me say, I think you will have to clean down. It produces 4 cubic meters of gas. So you be keen on that. It produces 4 cubic meters, because that's 12 cubic meters. It produces 4 to 5 cubic meters of gas per day. 4 to 5 cubic meters of gas per day. And remember, I talked about the quality of the gas is 80 to 85%. methane levels, right? 80 to 85% methane levels. And we have plenty of materials which we use because we are targeting waste biomass. And remember, we are within a region which has got plenty of the cow dung. Okay, our kitchen produces plenty of kitchen waste. So raw materials is not a big issue. Okay. And remember, we are endeavoring to clean up the environment, of course, of wastes, solid wastes, and of course, effluents, right? Going forward, we are doing a bigger plant here. This is a 75 cubic meter plant, and we are targeting 20 cubic meters of gas per day. 20 to 25 cubic meters of gas per day from that. So I think that will be a big boon for the university gas energy production and the gas needs.